Time for a cheeky bit of polar integration for you further maths addicts out there here at My Headspace Maths with me, Nick. Let's go. So we've got here in blue our curve defined in polar coordinates as r squared is 2 cos 2 theta, with theta between 0 and pi over 4. That is theta is 0, theta is pi over 4. First of all, the point P is a point such that the tangent to the curve is parallel to the original line. Our job is to show that the coordinates to P are this. This is in polar coordinates, so r is 1, theta is pi over 6. Then we need to find the area of R. So just a reminder, y is r sine theta. So if we want to differentiate that, dy d theta becomes dr d theta sine theta plus r cos theta. That's going to be useful because we need to find the point P. So let's have a little look-see. Now, r squared is 2 cos 2 theta. So if I differentiate with respect to theta, 2r dr d theta is minus 4 sine theta, minus 4 sine 2 theta. Never be afraid of a cheeky bit. As soon as you've got squares in there, don't be afraid of a cheeky little bit of implicit differentiation, because this is going to do something cool for me. Okay, so this does tell me that dr by d theta is minus 2 sine 2 theta over r. Okay, fine. Don't worry about the r yet. Don't worry. Okay, if we have to deal with it, we'll plug it back in. But because this is in terms of r squared, I don't really want to end up with square roots just yet in my life. So I'm going to leave it like that. So let's plug that back into this. So end up with minus 2 sine 2 theta over r sine theta plus r cos theta. And because we are parallel to the x-axis, essentially, dy d theta is 0. Now, what we can see here, which starts making a lot more sense as to why I felt I could, is what if I multiply everything by r? I'm also going to use my multiple angle formula, my double angle formula on that one. So sine 2 theta is sine theta cos theta, with the sine theta there. And then this becomes an r squared cos theta. And what's kind of useful here is we could already see that cos theta has to equal to 0, but that would be at pi over 2, which is outside of our limit. So bye-bye cos theta. It was nice whilst it lasted. And now we have an r squared by itself. So what we need to solve is r squared, which is 2 cos 2 theta, is equal to, move that over to that side. Now that is 2 minus 4 sine squared theta using our using double angle formula again. So we end up with here, if we rearrange just a tad, sine squared theta has to equal to 1/4, which gives me sine theta is plus or minus 1/2. But bear in mind that theta is between 0 and pi over 4. We only want the plus 1/2. So that gives me sine theta, so that gives me actually theta is pi over 6. And then r squared becomes 2 cos 2 theta, 2 times pi over 6 is pi over 3. So that becomes 1. R is positive, so r is 1, which gives me r is 1, theta is pi over 6. Boosh. That was a little bit more involved than we possibly would have liked. But hey-ho. Now, what are we going to do to find this area R? Well, what we are going to do is this. I don't know, let's call this point there point A. It doesn't really matter. Okay, but the idea is this. We can easily find the area of the triangle OAP. We can find the area of that green thing, and then we can figure it out. So let's start with the area of the green part. So remember, we are going from P is at pi over 6, and we are going up to pi over 4. So that area there of that sector, as it were, remember, is 1/2 the integral of r squared d theta. So we need to do, we're going from pi over 6 to pi over 4, to r squared, which is quite handy for us. And again, we're quite happy these go away. So we are left with sine 2 theta over 2 between pi over 6 and pi over 4, which will give me 1/2 minus root 3 over 4. Sine of 2 theta over 2 pi over 6 is sine of pi over 3, which is root 3 over 2. So that is my green gubbins. Okay, so we know a few of these. Now, this is pi over 6 and r is 1, obviously. So we can know that this distance there, which is our y value, is r sine theta, which is 1/2. And that distance there is r cos theta, which is root 3 over 2. So the triangle OAP becomes 1/2 times 1/2 times root 3 over 2, which is root 3 over 8. So the area R that I want is going to be the big triangle, and let's tidy this up. Root 3 over 8 plus root 3 over 4, that is 3 root 3 over 8 minus 1/2, which is exactly what we wanted. Cheeky. Very nice little bit of polar integration right there, or integration in polar coordinates, and some differentiation, all of that polar calculus in one. Did you enjoy this? Please do like the video, drop a comment, hit the notification bell, tell your friends, post about it on social media. Here at My Headspace Maths, really cool maths across the spectrum, no matter your level. There is something for you. Come check it out. We're posting content every week or so across, or 3 a week, 4 a week, whatever, all the time. Just come check it out. Hear me, Nick, lost my chain of thought. I'm just going to say bye-bye. See you soon.